Hello everyone, we have a question which says that coplanar forces of magnitude 8 Newton, 12 Newton, 10 Newton and p Newton act at a point in the direction shown in the diagram. What are coplanar forces? Coplanar forces are basically those forces which act at a point, at a single point. If you look at the diagram, we can see that the P Newton, 8 Newton, 12 and 10 Newton, they all are acting at this particular point. Therefore, all these four forces are coplanar forces. The condition that they have given us is the system is in equilibrium. Find the value of P and theta. So equilibrium is the condition. That means the opposite forces are equal. And opposite forces equal means the opposite horizontal forces are equal and opposite vertical forces are equal. And before that we could find the component. Let us understand what the components are. I have seen that most of the students have a misconception that the horizontal component is always a cos component. No, it is not like that. If this is the angle theta which is given us in the diagram, then the side next to that is a cos component of that particular force and the opposite side would be a sine component of that particular force. But if the angle given to us is this one, then the side next to that would be a cos component of that particular force and the third side, which is the opposite side, would be a sine component. That means it is not like that horizontal is always cos, it depends upon the angle. Because the condition that they have given us is the condition of equilibrium, that means we have to split up the given forces into components. 12 Newton, which is purely a horizontal force, that means no vertical component for this 12 Newton. For this 8 Newton with an angle of 30 degree and this angle is with the x-axis, so the horizontal component would be 8 cos 30 degree and the vertical component would be 8 sin 30 degree. For this particular P Newton with an angle of theta which is with the x-axis, the horizontal component would be P cos theta and the vertical would be P sin theta. And for this 10 Newton making an angle of 45 degree and this angle is with the x-axis, that means the horizontal component would be 10 cos 45 and the vertical would be 10 sin 45. We have splitted up all the forces into horizontal and vertical. The condition is an equilibrium, and when we say equilibrium, that means the opposite forces are equal. So first of all, work on the horizontal forces. We can see we have two forces over here. They have a direction in the left and two forces with the direction to the right. Because the condition is an equilibrium, that means the sum of these two would be equal to the sum of these two. That means P cos theta plus 10 cos 45 would be equal to, because equilibrium, it would be equal to 8 cos 30 degree plus 12, which we have written over here. Now 8 cos 30 degree plus 12, moving this 10 cos 45 over there, subtracting it, and after simplifying that we have 11.857, which is equal to P cos theta as an equation 1. So we have found an equation from the horizontal forces. We can find another equation from the vertical forces. We can see we have two vertical components, P sin theta and 8 sin 30 degree pointing upward, and just one force pointing downward as 10 sin 45. That means the sum of these two would be equal to 10 sin 45. We can see over here P sin theta plus 8 sin 30 degree would be equal to 10 sin 45. Why we have made them equal? Because the condition is in equilibrium. Now 10 sin 45 minus 8 sin 30 degree after simplification would be 3.07, and that is equal to P sin theta. We have two different methods to solve them. Both the methods are very easy. So the first method is dividing equation 2 by 1. That means P sin theta divided by P cos theta would be equal to 3.07 divided by 11.857. By dividing, we have this answer. Cancelling P, sin upon cos is tan, and then taking the tan inverse of 0.259, we have the angle. Placing this angle in any of the equation, whether equation 1 or 2, if we take equation 1, which is P cos theta is equals to 11.857, placing this angle over here cos theta and dividing by 11.857, simplifying, getting the value of P. The next method is also very easy, which is squaring and adding equation 1 and 2. That means squaring and adding equation 1 and 2 means P cos theta with a square and P sin theta with a square, and then add them up. So first of all square them and then add, and 11.857 with a square plus 3.07 with a square, because squaring and adding. After simplifying this, we have 150. Opening up the bracket, simplifying, we have P square cos square theta from here, P square sin square theta from here. Taking P square as common, we are left with cos square theta plus sin square theta, which is an identity equal to 1. We are just left with P square equal to 150, taking square root, and finally we have the same answer of P which we found from the first method, and then placing this value of P in any of the equation, whether 1 or 2. For example, if we take equation 2, P sin theta is equals to 3.07, placing this value of P over here 12.2, and then dividing, getting this, and then taking the sine inverse of this would give us the same answer of theta 14.6, which we got. You can have a slight difference up to 0.1 decimal, it is acceptable, so no need to worry. So you can use any of the method, both the methods are super easy.